So this is the 5th video covering activity 4.5. We continue where we left off with problem number 26. Again, using my table method, we're going to ask ourselves what two numbers, when multiplied, result in the last term, but when added, result in the middle term. And this is supposed to be a multiplication symbol. There we go. Okay, so the last term was -4, the middle term is +3. So you might be tempted to say, okay, Mike, 2 times -2 is -4, but the problem is when I add these together, I get 0, so that doesn't work. So we have to try maybe 1 times -4, right? That would result in -4, but when we add this, we have -3, so that's no good. So what about -1 times +4? When I add those two together, I end up with +3. Okay, so that's our winner, right? What two numbers, when multiplied, result in -4? Well, -1 times 4 work. And when I add these two numbers together, I end up with +3, which is our middle term, and that's what we need. So to write your final answer, you would write down b minus 1 times the quantity of b plus 4. And we are finished with this problem. Let's take a look at number 28. Okay, so we'll ask ourselves, what two numbers, when multiplied, result in -24? And when I add those same numbers, I should have the answer of 5. So I'm thinking of 3 times 8, right? If I did -3 times +8, that would result in -24. And when I add -3 plus 8, my answer is 5. So that's my winner. All right, so we're going to write x minus 3, and x plus 8. Okay, so that's my final answer. And then the last one, number 30. Well, the what two numbers, right? The table doesn't work yet because my leading coefficient has to be +1. So if I divide everything by -2, or if I factor out a -2, right, you divide each piece by -2 or each term by -2, we end up with x squared minus 6x plus 5. Okay, right? If I divide each of these pieces by -2, what's in my parentheses would be what's left over. Now, we're going to ask ourselves, okay, what two numbers, when multiplied, result in 5, right? Because the 5 is my last term. And when I add those same two numbers, I end up with -6, right? My middle term. So I'm thinking, let's see, how can I get 5? Well, 1 times 5 equals 5. And when I add that, I end up with 6. So I need -6. So how about we try -1 times -5. That results in +5 when we multiply. And when we add, we end up with -6. So this is my winner. So don't forget about the -2. We have to write that. That does not just disappear. And then we write x minus 1 times x minus 5. And we are finished. Okay? Now, we have this factoring the difference of two squares, right? And this is a formula or a rule that is definitely handy to memorize. Commit this to memory, right? If I have, there we go. If I have a squared minus b squared, the result will be a plus b times a minus b, right? Or the quantity a plus b times the quantity a minus b. If I were to use FOIL on the quantity of a plus b times a minus b, you end up with a squared minus b squared. So this one is really handy to memorize, okay? So when I look at number 10, or example 10, right, you can think of the x squared as the a term and the 4 as your b term. So instead of 4, couldn't I write this as x squared minus 2 squared? Right, now that now starts to look like this a squared minus b squared. So we're going to end up with x plus 2, x minus 2. And that's it. That's all there is to it. Okay, let's take a look at example 10. Or I'm sorry, example 11. All right, so example 11, think of this 49 as 7 squared minus a squared. And by using that rule, we can write 7 plus a times 7 minus a, right? That's coming from this rule up here. A squared minus b squared is a plus b times a minus b. Okay, let's take a look at number 12. All right, number 12, we have a little bit of work to do first. Right, we don't have a squared minus b squared, but if we factor out an 8x, we might be able to use that formula. So I'm going to write the 8x on the side. And what are we left with inside? Okay, so if I divide each term by 8x, I'm going to be left with x squared minus 25. And now the x squared minus 25, really, you can think of this as 8x times x squared minus 5 squared, which would be the same as 8x times x plus 5 times x minus 5. And that would be my final answer. Okay, let's keep going. All right, so now we have some practice problems. Again, we're going to work through the evens. Okay, so when I look at problem 32, right, again, you can think of this as y squared minus 2 squared. So that's going to become y plus 2, quantity, times the quantity of y minus 2. Okay, when I look at number 34, right, you can think of this as t squared minus 9 squared, right? 9 times 9 is 81. So then this is going to become t plus 9 times the quantity t minus 9. Right? Number 36, well, remember, 1 and 1 squared are the same. So I can actually write 1 minus w, or 1 plus w, times the quantity 1 minus w. Yeah, that would be my final answer. Okay. And if we move down to number 38, okay, so 38, it's not in the form of a squared minus b squared. So first I'm going to factor out the 5, and that would leave me with x squared minus 4. Right? Remember, if I factor out a 5, I have to divide each term by 5. So think of this as 5 times x squared minus 2 squared. So that would leave us with 5 times x plus 2 times the quantity of x minus 2. Okay, and that's my final answer. Again, don't forget to carry that 5 down. Right? The 5 doesn't disappear. And then number 40, the last one, I think we're going to factor out the 9 first. And we're going to be left with x squared minus 25. So we'll think of this as 9 times the quantity of x squared minus 5 squared, which becomes 9 times x minus 5 times the quantity of x plus 5. Okay, and we're finished. And by the way, people always ask, does it matter the order? For example, if I had written 9 times x plus 5, x minus 5, both of those answers are correct, right? Either one. Right, this is correct. This is also correct, right? The order does not matter. Okay, so I think I'll stop here, and then we'll finish up solving quadratic equations.